Alright guys, in this tutorial we're going to be talking about mole concept and this seems to be one of the most challenging topics for a lot of students and in addition to that it is one of the most important topic, if not the most important in chemistry. If you understand how to use the mole template, how to find the number of moles, the atoms, and the grams, it makes your life a lot simpler when you do rest of the chemistry, and that includes the stoichiometry. So let me start out with this random question. Health expert says we should drink about 2 liters of water every day. And if you're drinking that much water, that's very good, but a lot of time it's very hard to keep up the amount of water that we drink every day. But have you guys ever wondered if you're drinking 2 liters of water, how much or how many molecules of water you are intaking in that amount? That's something to think about, and we'll answer this question as we move along in the session. Before we actually jump into the mole concept and the mole template, some of the terms you want to make sure you understand what they mean and how to calculate those if they need to be calculated. The atomic mass, make sure you know how to calculate, how to retrieve the atomic mass from the periodic table. Make sure you know how to calculate the molar mass from the periodic table. And if you have a hard time understanding what those means, I have another tutorial just on the atomic masses and the molar masses. Make sure you watch those. And then the Avogadro's number, and I'll talk about that in a minute. In addition to that, know what the density and volume as well, because sometimes if they don't give you the mass, they may give you the volume and density, and using the density definition, you would have to find the mass in those particular cases. Well, let's talk about Avogadro's number. Avogadro's number is actually a dozen for a chemist. You know how 1 dozen has 12 things in there, so that could be 12 eggs or 12 bananas and stuff like those. Avogadro's number is just like a chemist's dozen. Obviously, it's not 12, it's a lot bigger number. One, what that really means is 1 mole of anything is gonna have 6.022 times 10 to the 23 atoms or molecules or particles. Literally means anything. I could talk about photons, I could talk about ions. If I have 1 mole of anything, that's how many numbers it's going to have. Just like, we can use dozen for any particular fruit. We can talk about 1 dozen bananas or 1 dozen oranges. That's going to have 12 bananas and 12 oranges. Same story. 1 mole of anything will have that many atoms or molecules or particles in there. So make sure you have this number memorized, which is 6.022 times 10 to the 23. And it may seem like you can't really memorize this number, but when you use this number so many times when you're doing these problems, you will have it automatically memorized. Okay, so the mole template that we're just going to talk about now is all based on those 3 things. We're going to have the mass, the moles, and the number of atoms, molecules, ions, or particles. So those are most likely going to be your 3 variables. You could be given either one of those and will be asked for the other 2. Okay, and it's just a way how you're gonna go from point A to point B. So there isn't a mole template that talks about how you can go from point A to point B. So let's focus on this graph or this template that I have made. On the left side, I have this mass or the amount. So for the most part, you will be given the mass, but sometimes, occasionally, they may give you the volume, and if you're given the volume, you may have to use the density to find the mass. Okay, so if you know the mass, which is going to be measured in grams, then you can find the moles. Okay, and when you go from mass to moles, you're going to be using a conversion factor of atomic mass. Okay, either you use atomic mass or the molar mass. Now the question is, when do you use the atomic mass and when do you use the molar mass? Well, the answer is simple. If you're using an element, then you use atomic mass. All right, so the atomic mass is for the element. And if you have a compound, then you got to worry about the molar mass. A compound or a molecule will be needing a molar mass there. So obviously you're not using both of those, but it's just either the atomic mass or the molar mass, depending on what your starting point is. Then going from moles to the atoms, you're going to be using the Avogadro's number. All right, so the Avogadro's number is going to be 1 mole of anything is going to be equal to 6.022 times 10 to the 23 atoms, molecules, particles, ions, photons, literally anything. Now, the good thing about this second equality where I have the Avogadro's number, that never changes. It's always going to stay the same. However, the atomic mass and the molar mass equality will change. That's because different elements has different atomic masses and different compounds have different molar masses. So your first equality going from mass to moles or reverse will change. However, going from moles to the atoms or reverse will always stay the same. It's always going to be the Avogadro's number. Okay, make sure it's very important to understand this template and make sure you have this synced in. Now, the very first question you ask yourself when you're trying to solve a mole concept problem is ask yourself what you're given and where you are on this template. So if you're given the mass, then you're on the left side, and then you may be asked to find the moles, or you may be asked to find the atoms or molecules. If you're given the moles, then you may be asked to find the mass or the atoms. So it just depends on where you're at. If suppose I'm given aluminum, I'm given the mass of an aluminum sample. Okay, so I can go ahead and convert that mass of aluminum sample to the moles of aluminum. Okay, and then from the moles of aluminum, I can go ahead and convert it to the number of atoms of aluminum. Okay, now let me write down another one, and I want to make sure you figure out what the difference is between those two lines. Suppose I'm given the mass of mass of salt, and we'll just take this table salt, which is NaCl. Okay, so if you're given the mass of the salt, we can go ahead and convert it to the moles of salt or moles of NaCl. Okay, and then from there, I'm going to be converting to the molecules of NaCl. All right, so this is where it makes a little bit difference. The molecules, or these molecules, are also called the formula units. So if they say formula units or the molecules, they're more or less means the same thing of NaCl. Okay, so keep in mind I did not go straight to the atoms just like I did in the previous setup. And that's because in the previous setup, you were actually dealing with an element. So it was an aluminum sample, which means it was just an aluminum element. So when you're going from an element, then you can go straight to the atoms of that particular element. But if you're dealing with a compound, like in this case, in the second particular case, we have a compound, or even if you're dealing with a molecule, then you first go to the number of molecules or the formula units of that compound, and from there I can go ahead and convert it to the number of sodium atoms or number of chlorine atoms. All right, so you'll have an extra extra step to go from the formula units or the molecules number to the number of atoms. Okay, so I'll have some more examples down there so that way you know what the difference is. But keep in mind, if you're starting out with an element, you can directly get the number of atoms after finding the moles. And if you're starting with a compound, you will first get the number of molecules or the formula units of that compound before you can get to the atoms. So that's an extra step in there. So that's why this equality, when we wrote down the Avogadro's number, we have everything written out here, the atoms, the molecules, the particles, and all those things. Okay, so when you're coming backward, you're still going to be using the same equalities, but their orders kind of changes. So it all really depends on where you're starting and where you're going to. So let's go back to that question that we asked initially that, okay, if you're drinking 2 liters of water every day, how many water molecules are there? So 2 liters is actually the volume, which literally means the amount of water. So if I'm given the amount of water and if I'm trying to find the molecules of water, well, in this mole template, I'm actually right here given the amount. And in the first step, I would have to convert it to the moles. And then in the second step, I would convert it to the molecules. Now remember, water is actually a compound, so you can go ahead and calculate the molecules after finding the moles. If they had asked you to find the atoms in there, then you would have an extra step, and I'll show you that example in another video. So my plan is, if I know the amount of water, so I want to go ahead and convert this to the moles of water. And once you have the moles of water, I can convert it to the number of molecules of water. Okay, so to go from the amount of water, which in this case is I'm going to have in the grams here, so we have to figure out how you convert the liters to the grams, but we'll do that in a minute. So the grams of water to the moles of water, I would have to use the molar mass as our equality. And what's going to be the molar mass for water? Well, water is H2O, and when you look up the atomic mass for hydrogen, which is 1.01 times 2, and then plus oxygen is about 15.99, so that's going to be roughly 18.01 grams per mole. Okay, so that's going to be the molar mass for the water. Once you have the moles of water, you can go to the molecules of water using this equality. 1 mole of H2O is going to be equal to 6.022 times 10 to the 23 molecules. Okay, so let me just go ahead and write it out now. 2 liters of water is actually going to be equal to 2,000 milliliters. Okay, and if you recall, the density of water is actually 1.00 grams per milliliters. What that really means, if I have 1 milliliters of water, it's exactly going to be 1 grams. If I have 800 milliliters of water, it's going to be exactly 800 grams. So if I have 2,000 milliliters of water, it's actually going to be 2,000 grams of water. So now you have the starting point. Now you have something that enters this mole template. And after that, it's all about setting it up. Okay, so if I'm starting out with 2,000 grams of water, and in the first step, we trying to go to the moles of water, so I'll put moles of water on the top, and we're trying to get rid of the grams of water, so the grams of water goes on the bottom. All right, so we already have this molar mass written out, so we have 18.01 with the grams, and with the moles, it's just 1. If there's nothing in the denominator, that means it's just 1. So make sure you write down the correct numbers that goes with those grams and the moles. So 1 is going to go with the moles, and 18.01 will go with the grams. Now, after doing so, the grams of water cancels out. And then in the next step, what we have to do, so once you find the moles of water, you are halfway right there, and you have to go ahead and find the molecules of water. To find the molecules of water, I would put molecules of water on the top, and I would put moles of water in the denominator so that this moles of water cancels out. So the moles of water cancels out here, and then we can go ahead and plug in the numbers here. So what number goes with the molecules and what number goes with the moles? Okay, if I go back and look at these equality, I know 1 mole of water is going to be the Avogadro's number. So whenever you're using the equalities that involves the mole or the conversion factor that involves the mole, mole is actually always going to have 1 with it, unless you have the moles outside given. But if you're using that in the equality, it's always going to be 1. Okay, so that kind of takes care of all the units. At the end of the day, we'll have the molecules of water left here. And now all I really have to do is just put this in the calculator. And we got 2000 times 6.022 times 10 to the power 23, and obviously divide all that by 18.01. If you have a multiple choice question, then you can always estimate by just kind of doing in a rough calculations. So it's going to be 6.69 times 10 to the power 25 molecules of water. So think about this. When you're drinking 2 liters of water, you are actually intaking 6.69 times 10 to the 25 molecules of water. So that's actually a lot of molecules of water to take in, but that's just what the reality is. All right, so that's how you calculate the mass. That's how you use the mole template to find the molecules. And I'll have another video where I'll do multiple examples explaining how you go from the grams to the moles and to the atoms and reverse. All right, if you have any questions, feel free to leave any comments in the section below.